Welcome everyone to this technical demonstration by Digital Craftsmen. Today we're going to be building a development platform using CloudFormation, which is a declarative template format for building infrastructure, machines, load balancers and everything you need for your system. So without further ado, let's have a look at our lab AWS account. If you're just about to embark on your AWS experiences, you might well come straight into the EC2 section, start launching instances from some of the AMIs that are available, and then hang it all together and slowly grow and evolve your development system. However, we have a much better way of doing this. As I said, we're going to be using CloudFormation to build the system. This enables us to build consistent and repeatable development environments, or even production environments that are utterly the same as your development environment, and therefore you can be assured that whatever you release into your development environment should work in exactly the same way as your production environment too. So we've got a template here to build us a development environment. This is one we've created in-house, and it's going to ask us for a few details about the system that we're about to deploy. In true demo fashion, here's one I've already entered some details in earlier. So we're going to call this system My Development Environment. It's going to be deployed into EU West 1, which is over in Ireland. We do have the option of creating an RDS database as well, and in this case we are going to create one. We're going to make a WordPress database, and we're also going to specify the password for that database, which will be demo. The username, which development tool we want in the environment, be it GitLab, Jenkins or Maven. This will spawn a pre-built appliance within your virtual private cloud on AWS. What domain name we wish to use with the system, the key name that you're going to be using to access these management machines, the management email which you're going to get feedback on about the creation of the stack and other details. Where you would like to lock down management access to, we would suggest a range of IPs, but in this instance it's a demo. I'm not going to lock it down, and it's going to be accessible to the public. The management password, we're also going to specify demo, and we could also change the subnets and the CIDR for the entire virtual private cloud if we wish to at this stage also. So let's kick that off, and I'll explain a little bit more about what we're going to be building. Right, now that CloudFormation has started, it will go and build us the environment, and this is what it's going to build for us. This is the Amazon region, the exterior boundary of our system here. And within the Amazon region we're going to be building a VPC, which is our virtual private cloud. And within the virtual private cloud we're going to be splitting it across 3 availability zones, availability zone 1, 2 and 3, and each availability zone will have a private subnet and a public subnet. I'll explain a bit more about these later or in another video. But it's a fairly common AWS type setup that you'll see within a VPC. We're also going to have a gateway for access to the internet, a foreman or puppet server which will be used for management and for controlling configurations across the machines, a log server so your developers can visualize logs in real time both from your applications and from the operating systems. We'll be using Greylog for this. And a standard VPN server or Bastion host by which you'll access this environment. Otherwise, they're all on private subnets that can only be accessed from within the VPC, or unless you attach an EIP up to an instance. We've opted not to create a development instance in this particular test. No GitLab or Maven is required, but we will be building an RDS instance so we can show in the demo later a couple of web servers connecting up to RDS in our fully built and working environment. Right, the actual process, let's flick back to the AWS account, takes around about 7 to 10 minutes to complete, depending on how busy AWS and its CloudFormation workers are at that point in time. But once complete, we'll come back to this and we'll log into our newly created instances, and we'll start configuring some of the system for us. Okay, this shouldn't take much longer, so let's get back to our slideshow. This is a great way to kickstart your AWS project. We can set up a secure development environment on AWS, and it can be done within half an hour. If you're building your own environment with some of the additional features and functionality that we've managed to cram in here for you, it could well take you a great deal of time, expertise and research to get to that level. Thankfully, this means that great barrier for deploying and running your code on AWS has been removed entirely. Rather than having to know all about AWS and the services it provides, effectively we'll be deploying you a platform as a service for development activity. And this will automate the creation of your environment without any of those time and cost implications. So CloudFormation is a great tool. It's a declarative template language. It allows you to define infrastructure as code. And once infrastructure has been defined as code, it is consistent and repeatable. You can version your changes to the infrastructure, which means you can roll back and roll forward on an infrastructure level. You can apply change sets and audit to your changes. Therefore, you know exactly who to blame and for what reason. If anything fails during a CloudFormation deployment, you will find that it's got automatic rollback built in to prevent anything from going wrong with your environments. And it's the great tool for automating the blue-green deployments that people demand for zero downtime these days. CloudFormation, in this instance, is going to deploy us a Puppet and a Foreman server. This will be installed afresh on a brand new CentOS AMI, as will the Greylog server that we'll talk about in a moment. Foreman is a graphical user interface and external node classifier for Puppet. It allows us to control machine configurations, to view their details, and also provision machines all from one interface. It will manage DNS for you within the environment. It will allow you to remotely execute commands across the instances and orchestrate their activities, as well as integrating with AD or LDAP and providing audit trails for all the users and all the roles that are built into it. We've also configured this particular version of Foreman to control power states of your instances, which is great for development teams who only work during core business hours and really don't need to leave servers switched on out of hours, saving costs and the environment too. We'll also be deploying a Greylog and a VPN server as part of this environment. And Greylog is a fantastic tool if you haven't used it before, providing real-time log analytics. It lets us define inputs from the applications and from operating systems, and it collates together all of that information and log data and puts it into one interface that's very easy to use, search through, and drill down to. It also lets you set events and triggers based on your logs. So if a log with a particular value comes through, perform this action or run this script. And in this instance, it's controlled and managed by Puppet. Similarly, we've got a VPN or Bastion host that provides secure access into this environment, the virtual private cloud, and it again is controlled and managed by Puppet. Okay, so I've sped things along a little bit, and our environment should now be created. Let's get back to the EC2 console. We can see that the system and the stack has been created successfully. If we have a look at the events for the stack, we can see a whole load of information about the actual components it's been building for us in the background. Now, in the output section, it will give us details about the IDs, the subnets, the internal IP addresses, the external IP addresses for your environment, as well as the secret keys and the access keys, which you might well need to interact with the system. This should all be private under normal circumstances, of course, but thankfully this particular environment will be deleted just a few minutes after this demonstration is concluded. Um, I'm going to take these external IP addresses. I've added them into my hosts file so I can directly access the machines, but you might like to add them into your DNS provider or Route 53 record. So let's access the environment and see what's been built for us. We log in with the admin and demo, which is the password we specified when creating the CloudFormation system. Also see if Greylog's up and running, and we'll log in with that same demo password. All these systems are built afresh upon vanilla AMIs, so we'll be using the password that you specified when you created them on the CloudFormation template, but we highly recommend you come in and alter your password at a later date. Greylog is a fantastic tool if you haven't used it before. It allows you to set various inputs and outputs, for that matter, for your log files, be they application logs or OS logs. You've got a whole range of inbuilt inputs already, and you can launch these inputs to start accepting messages from your application or from your operating systems. Even supports Windows Event Viewer, as well as streams and triggers to perform actions based on certain events. But really this is a great tool for your developers, where they can look in real time about the logs coming back from the machine. They can drill down to a particular period in time and look at specific logs over quite a granular period. I mean, we haven't actually got many logs in here just yet, but over the course of this demonstration we should find that quite a few logs are building up within this tool. Let's see if we drill down to those particular minutes. You can see that the query bar is reflected, and when we search we just see the logs returned for that brief section that we've highlighted. Right, so this is the Foreman and Puppet server that we've created for you. We've got a nice overview here, but also we have a list of the hosts available in this section. We can select all of them, we can perform certain tasks, we can remotely execute commands on them. In this instance, if we just have a look at the etc password file on each of the servers and submit that, we should start getting some real-time information back from the servers about how that command's gone, the output of it, and what uses each machine has available. Needless to say, this is quite a powerful tool and great when you're managing many machines within a development environment. So we can execute commands remotely on all of the instances in the environment. All the instances also configured with a dev admin user, so you can gain access or provide access to your teams. They are all automatically configured to ensure that the logs are coming through to the Greylog system, and this should be building up quite a decent amount of logs now. There we go. But what we can also do with Foreman is not only can we provision new machines through this system, but we can also configure machines through the system as well. So if we have a look at our VPN server and edit the configuration for it, you'll find that we can start adding things to the VPN server, or even changing its current parameters. But in this instance we're going to add a few components to the machine, so we can start our demo off. I'm going to add EPEL onto the machine, which is a standard repository that you tend to find on EL based operating systems, and wget, as we'll need that momentarily as well, and we'll submit those changes. And let's move on to the VPN server itself, and we'll do a Puppet run. We've now controlled the configuration on the Foreman interface to install wget for us, and also to install EPEL for us. That particular connection appears to have timed out on me whilst going through a run, which wasn't particularly helpful, but we'll start that off again and we've probably missed it to be honest, but the system will have installed EPEL and wget for us. We know that because if there had been any additional changes to be applied, Puppet would have done that on any subsequent run. So we've updated the configuration for the VPN server, but it's not yet a VPN server. So first of all, we're going to configure the Puppet class. And at this stage, I'm just going to expand this window slightly to let me get a bit more on, but you might find that some of the left-hand side is chopped off for you. Okay, within the OpenVPN class itself on the Puppet server, we can start overriding parameters. And for the VPN server, we're interested in overriding, a bit bigger, refresh it. We're interested in overriding the clients and the server section. So if it will, with the JavaScript, will allow me to select the server section at this particular resolution. It won't, so we'll have to increase it slightly more. There we go. I should be able to override this string with a block of JSON, and we'll define that in a moment. And we're going to do a similar thing for the clients section as well. So we'll override the string with a block of JSON and take out the default value. We're going to submit those changes, which unfortunately is just off the screen, but if you trust me that I've submitted those changes, we should now be able to go back towards our VPN host and configure those options and install the actual VPN software itself. So if we go back into Puppet classes, we have curated a number of Puppet modules for you to give you functionality straight out of the box. One of those is OpenVPN, so now that we have added OpenVPN to the system, we'll find that we can override these values too. So for clients, we're going to paste in the clients that we're interested in, and for servers we'll do the same. Try and make this a bit bigger again. There's a really distinct cut-off point for this JavaScript. I do apologise. I'll moan at the developers one day. So we'll paste in our block of JSON that defines the VPN server itself, as well as some details about it and what subnet it will be assigned to the clients. And we'll paste in a further block of JSON that will define our clients as well. So a test1 user, a test user, and a user for myself. Okay. Let's submit those changes. And if we go back to the VPN server itself, we'll force another Puppet run. Ordinarily this would take about 30 minutes to complete, because the Puppet runs happen every 30 minutes. But in this instance, and for the purposes of this demo, we'll push this through a bit quicker and install OpenVPN, set up our server and all of our clients. All that remains now is for you to exfiltrate the configs which have been created within etc. OpenVPN download configs. And all you need to do is take these OVPN files, take these OVPN files from the VPN server, give them to all of your clients, and then they'll all be able to connect up to this VPC securely, and as if they'll be connected to the local network. Right, so that's your VPN server all set up and configured. If we go back to the host section, let's see whether we can provision ourselves a new host as well through this Foreman system. I hope so. That's the purpose of the demo. So without further ado, let's make a WordPress instance. We'll give it a default host group, which will define some default characteristics about where the log files are going to go, dev admin user, and the fact that it should have Puppet installed and running. We're going to install this instance on EC2, and we're going to also define the operating system. We don't have to define the classes just yet. This one's included in the default host group, however. We don't have to define the interfaces, as Amazon will take care of all the address allocation for us. We do have to tell it what operating system we want, and we've installed 3 different operating systems for you here to choose from. These can be updated and added to if you have any requirements, but these 3 should get you started. There's an image for each of the operating systems, and you can also specify a root password, or in this case a dev admin password when you're provisioning the host. The root account will still have the key associated with it, as per all EC2 instances. We have a user provisioning template, or a cloudInit template here, that will take care of all the provisioning for us. And if we look on the virtual machine, we just need to define what type of instance we wish to run, if we have a preference for the availability zone, or which subnet we would like to put this particular machine in. Now if we quickly go back to our diagram, we can see here that the first public subnet is 10.0.0, and the first private subnet is 10.0.1.0. So we're actually going to place this within the private subnet. And we're going to allow all people within our VPC to connect up to it. So that will be the public web access security group, and it's going to be a private IP address. So if we submit this, our instance should start to be built. And we'll have a bit of progress information about this particular build at the top. Effectively it's waiting for the AWS API to respond and tell it that this particular IP address has been associated to the new machine that's being built, and as a result it will be able to create its DNS records for that machine and confirm that the instance is up and running. There we go, it doesn't take too long at all. So this machine has been built with this internal IP address within the environment. As a result, we'll be able to connect to that momentarily when it has finished building. This will change from cancel build to built once the process is complete, and I will show you what happens in one moment. Okay, because we've built this machine within the private subnet within the VPC, we won't actually be able to connect to this from the internet. Unlike if you were to map an elastic IP to the machine, or have an elastic load balancer forward traffic through, you simply cannot connect to these internal IP addresses remotely. As a result, we will have to connect up to the VPN that we've just created. So if I run the VPN config that I just downloaded a few minutes ago, this should connect us up to the system and give us a private IP address within the VPC. We should now be connected, which means we can connect up to this newly created server. Okay, now we've created a dev admin user on all the instances that should be accessed with the same password you specified when creating the instance. You can also access the root user using the certificate that's defined by Foreman as well if you need to, but for the purposes of this demonstration, this should be more than sufficient. And if we just do a quick Puppet run, we should hopefully find that the machine has Puppet Agent installed and has the very latest configuration from the Puppet Master, which it does. Fantastic. Right, so how do we configure a machine within the environment, or how would your developers do this? They would simply come into Foreman, edit the particular instance that they're interested in, and as a result they can simply start adding the components that they require for their system. Okay, so let's add a Puppet class. We're going to need Apache definitely, as this is going to be a web server. This will install the default parts, not necessarily all the various components, but that should be sufficient for now. I'm going to install EPEL as well, just because it's very useful and generally necessary for most things. Let's install Git. We won't need MySQL in this instance because we are running an RDS server, and we'll be using RDS as our database instance, but we will need PHP, and we will also need wget. Let's do those components first of all. Go back to our WordPress server and rerun Puppet. Now you might notice the occasional bit of red popping up. This particular message is just explaining that we're not in a production environment, we're running in a development environment, and it's just letting us know. Okay, so that should be Apache installed along with some of those other components. Puppet is eventually consistent, so you might find that you get an occasional error, but as long as the configuration is sane, rerunning Puppet will ensure that all those components are in the desired state on subsequent runs. In hindsight, I shouldn't have used a small instance. Should have used something a bit more powerful, as it's only going to be available for a few short minutes. But that should be all of those various components installed for us as well. Let's go back to Puppet classes, and we're going to configure our WordPress class this time. And here we can see we've got a whole load of parameters with which we can control whether or not we wish to create a database. We're not in this case, as we have one already. Database user, we don't need one of those. Database host, yes, we will need a database host. We'll have the default value as localhost. Again, a database name, be nice to override, as will the password and the user. Install directory, which version of WordPress you wish to install, whether we want it to be multi-site, or whether we want specific directories or domains. We do want a specific domain, and we will also use a prefix as well, so that gives you a bit more flexibility in the future. Let's submit those changes. So we have configured our WordPress Puppet module. Let's go and apply it to our WordPress server. Try and bring that back in a bit. Now we've done with the JavaScript sections. Okay, so we've got these components already installed. They should all be complete, and once this is finished it will confirm it for us. There we go. So all of these components are currently installed. We're also going to install the WordPress component, as we mentioned before. And as a result, we can start creating and editing some of these items. Now, as part of the installation, we also set up an RDS server. So if we have a quick look on the RDS system within AWS, we should be able to find our brand new RDS instance that we've created as part of this. And I'm going to take the identifier for RDS in our environment, and I'm going to use that within our Puppet module. Let's try and expand this, as it looks truly horrible. You have to excuse me, but some of it will get cut off. That's a bit better. Hopefully you can see most of the screen there. So we're going to edit these variables. We're going to have a database called WordPress. The password again is going to be demo, as that's what we specified on the template. The username is root. The default path for Apache is var ww. The most recent WordPress I can think of is 4.6.1, and we're going to call this site wordpress.dcl.io. We'll leave the default table prefix, as that's pretty irrelevant for a single site, and we'll submit that. And we now have our WordPress config baked in for that WordPress site. Right, moment of truth. Let's apply our configuration and see how the WordPress server gets on. We're aiming for a WordPress server to be Apache server to be installed with the WordPress application deployed upon it. The modules should orchestrate all this for us, and we've just had to configure it via the GUI. So if we just force the puppet run again, just to make sure it's got no residual tasks left. Oh, and it has got a few. So this looks like it's actually unpacking WordPress there into the right directory, doing a brand new installation for us. Come on, puppet. There we go. I'll kick it off once more again just to make sure, because to be honest I wasn't expecting it to perform all those additional actions on the second run, so we'll give it one last try. And whilst it's doing so, we can get back to our foreman screen. Let's get the internal IP address for this server. I'm just going to add it into my host file for wordpress.dcl.io. It's the magic of my host file. There we go. Save that. And there we can see that all of the changes have been applied to that WordPress instance. Because I've added this now to my host file, I should in theory be able to simply type in wordpress.dcl.io and we will see the brand new WordPress installation. There we go. Thank you, demo gods. We have a WordPress installation. The site title, we'll call it wordpress.dcl.io or something highly imaginative. Admin with that password, which will store permanently in my clipboard. DCL.io. There we go. And that's how you install WordPress much quicker than the 5 minutes they suggest and that they're famous for. Admin password, and you have your WordPress installation. You might wish to do an update if you installed 4.6.1 as I did. I would recommend that you always update your WordPress installations, of course. Well, that's the end of the technical side of the demo. Let's quickly get back to our PowerPoint presentation. Onto the business benefits. Templated environments can save your teams hours. The benefits behind it are clear as well. Version control allows you to roll back and roll forwards your infrastructure. Change sets, which will complement your change management processes. The environments are consistent. This immutable approach to architecture allows for lots and lots of benefits, from disaster recovery through to zero downtime deploys and even zero downtime environments. Environments that your development and operations team can standardize around and support. In addition, these new environments can be created in less than 30 minutes. What I've just shown you is exactly as long as it takes. And all those environments will consistently be the same. This allows your agile teams to develop and not become distracted with this day-to-day tedium of operations. Okay, this is really a framework for AWS for configuration management, for auto-scaling, for getting all the best bits out of the immutable architecture and IaaS service that AWS provide us. You can save hours and hours of time and make your development teams much more effective with centralized logging and a real-time interface so they can view their logs and get real-time feedback as and when they're developing and working within these development environments. We can save you about 60% of your running costs for EC2 simply by scheduling the power states of instances and turning them off out of business hours when they're not in use. We've implemented security into this design, not only with roles in foreman and pre-configured security groups. We've ensured that your machines have security updates, that there's VPN access into the environment, and that all the orchestration and roles and IAM users and accounts that are used within this project are really locked down to the bare minimum permissions possible. So I hope you've enjoyed this demonstration. I hope it gives you some ideas about what you can do with AWS. So thank you for your time today. We've been Digital Craftsmen. These are our contact details. Feel free to reach out to us. We hope that you've enjoyed this demonstration of AWS and what could be done to create your team's development environment. And I hope you look forward to the next one. Thank you.